Calculate the entropy change of a sample of a perfect gas when it expands isothermally from a volume of Vi to a volume of Vf. So let's begin with the first law of thermodynamics. The first law says that delta U is equal to Q plus W. Delta U is the change in the internal energy. Q is the heat added to the system, and W is the work done on the system. Now, for an isothermal process, the delta U, or the change in energy, or change in internal energy, is equal to 0. So delta U is equal to 0. So our equation now becomes 0 is equal to Q plus W. That means that Q is equal to minus W. Now let's bring in entropy. So the change in entropy for a reversible process can be calculated as follows. So delta S, the change in entropy, is equal to the integral of dq ReV divided by the temperature in Kelvin. Now, for an isothermal process, the temperature is constant, meaning we can take the temperature out. So delta S is equal to 1 over T and the integral of dq ReV. So it is the heat of the reversible process. Now, we know that Q is equal to minus W. And we also know that for any gas that's expanding reversibly, we can calculate the work done as follows. So we can say W is equal to minus P dV. So that means minus W will equal P dV. And since minus W is equal to Q, this is also equal to Q. So we can now substitute that into our entropy equation. So delta S is equal to 1 over T times the integral of P dV. Now, we can bring in the ideal gas law to rewrite P in terms of V. So from the ideal gas law, we know that PV is equal to nRT. So P is equal to nRT over V. So we can rewrite that. So delta S is equal to 1 over T multiplied by the integral of nRT over V dV. Now N, R, and T are constants, so we can take that out as well. So delta S is equal to nRT over T. The temperature cancels, and the integral of 1 over V dV from the initial volume, so V initial to V final. And now we're basically done. Delta S is going to equal nR multiplied by the natural log of Vf divided by Vi. And this is our new equation that we can use to calculate the change in entropy for a gas, for a perfect gas when it expands isothermally. Now let's take a look at the next part of this question. Calculate the change in entropy when the pressure of a fixed amount of perfect gas is changed isothermally from Pi to Pf. So what do we need to do here? So we can go back to our original equation, or the one that we just derived. So delta S is equal to nR and times the natural log of Vf over Vi. So this is going to be our equation that we're going to be referencing. Now, if we look at our ideal gas equation, we know that PV is equal to nRT. These are constants. So P is inversely proportional to V. So in other words, Vf over Vi is going to equal Pi over Pf. And all we need to do then is to replace this Vf over Vi with Pi over Pf. So when the pressure of an ideal gas or a perfect gas changes isothermally, the new equation we can get is delta S is equal to Nr, the natural log of Pi divided by Pf. So this is when there's a volume change, and this is when there is a pressure change. Thanks so much for watching.